Okay, part D. What is the maximum amount, so looking for a max, not a relative max, of unprocessed gravel at the plant? So when is this amount here highest? That's a min max problem. That's going to require the Min Max Theorem. So grab from my memory, the Min Max Theorem idea is right here. Pull this up and cover up the problem for a second. Okay, we are finding the absolute max of A, the absolute max of the amount of gravel at the plant. Finding the maximum amount of A means we're going to have to do a candidates test. So we have to remember that the absolute max of A, so that's going to be A. So we should write A instead of scribbling it out. So the maximum amount of A here is always located at a critical or end point of A. Critical point of A is where A prime is equal to 0. Or A prime is undefined. The grader wants to see me write this down. A prime of t is equal to 0. So let's do that. So go back to my work here. First thing I do, I'd already done this earlier, so I don't have to do it again. Make sure the grader knows what A is representing. Make sure the grader knows what A prime is representing. I have to do the two purple lines. I won't get a point on the red, but I could have done the purple lines in an earlier portion of the problem. But once I do the purple, I write A prime is equal to 0 at a certain time. How do I find that time? I grab my calculator and I plot A prime. Here's my A prime formula. Because it is G, subtract 100. This is my graph of A prime. This is the time when the A prime value is 0. So that's what I wrote here. That's worth 1 point. You have to write that to get the point. You don't have to write this, you just have to think it. So A could be greatest, either at the very first time, the very final time, or at the time where A prime is 0. So now I get 1 more point for finding those values of A. A of 0 is given, I don't have to find that. I do have to find A at 4.923 and A at 8. Therefore, I use the fundamental theorem. I say integrating the rate at which the amount of gravel is changing will tell me how different is the amount of gravel times 0 compared to time 4.9. So this integral turned out to be 135 roughly, meaning that from this time to this time, the amount of gravel went up. Could have gone up and down, but the net change was 135. But we started with 500, therefore at this time, we now have this much gravel. Using the exact same argument, we find A of 8. We simply compare these three. One of those three will be the lowest amount of gravel that is ever at the plant during those 8 hours. One of them will be the highest amount of gravel that is ever at the plant during those 8 hours. Therefore, the correct answer, 1 more point for having a correct conclusion, is this is the maximum amount of gravel. I really should read my question again because this takes a lot of work and it's really easy to get lost in the work and then not answer the question correctly. So let's just make sure. What is the maximum amount of gravel? So we've got that, maximum amount of gravel at the plant during the hours. Yeah, it didn't say anything about finding the time. It didn't say anything about rounding. So we're good.